Welcome to this Panda demo. So the first thing I will do before I start the demo is warn you, Panda is not a carbon calculator. Panda is also not a cost calculator. These things Panda will do because this is part of the purpose and use of Panda. However, then it is not meant to be able to provide you with a detailed and precise guess or model of your costs. Rather, it is meant to help you decide what is the cost carbon trade-off in your designs, what are the possibilities, and help you be faster and better at scheme design at the early stage. I'm going to start a new project now. So when we click Start New Project, we see the designer open, and the designer is a very simple designer whose purpose is for you to input the massing of your structure. Now, I'm going to start the demo with a simple shoebox building. I will give it about 6 stories, add a basement, and the reason I'm using this as a subject for the demo is because this is perhaps the least interesting, most boring, lowest prestige building you could possibly imagine. Therefore, it is exactly the kind of building for which you would not normally spend much time optioneering, figuring out what is the best option. Rather, it's the kind of building, and it's the most common kind of building, where you would pick up from your existing roster of completed project, adapt, and use. However, we know, because we've done good academic studies, we know this will yield a very inefficient project. We find, in fact, that typically, even keeping the exact same layout, just choosing the right decking can save perhaps 25% of the carbon and perhaps up to 15% of the cost, give or take. Of course, if you then adapt the layout a little bit, the gains can be as high as 50% of the carbon and 20% of the cost of a frame. Then we go into Panda proper. Now you see, this was my editor, if I would need to go back to it. And Panda is laid out in the logical progression. First, I have edited my layout, my basic massing. What do I want Panda to model? I would like the foundation floor. I will set the bounds for the spans, from minimum to the maximum common spacing. If I have a very complex grid layout, it may be that it is desirable to have a fairly uniform layout. That is, I don't want to have part of the building with very large span and part of the building with very small span. And because Panda will try to give you all the options, if you have such a complex layout, this may be an outcome, and it's possibly not desirable. So I could prevent it from doing it here. I want it as open as possible. In any case, the massing is simple, so that should not be a problem. What will I optimize? I need to set my LCA cycle. I have a choice of LCA cycle from cradle to gate, cradle to completion, cradle to cradle. I have a cost model. Am I expecting a normally costed building? Maybe it's going to be expensive because of location and access. Maybe it's going to be cheap for similar kind of reasons. There's also an internal model that you can use. This one has been academically validated, but is more representative of the cost of things than the price. So perhaps it is not the most commercially relevant model. Then I can pick my materials, depending on location. In the UK, it would be USB universal columns. Maybe I'm in mainland Europe. IP section would be more appropriate. I can activate Weststock beams if I'm aiming for long spans, and they tend to be good for that purpose. The steel grays, the concrete grays, also and the timber grades, etc. Some detailing options. We know in real life the utilization ratio, that is how close you are to what the code allows, tends to be 0.8. By default in Panda it is 1. The idea of Panda is to give you a benchmark of what is the best structure you could achieve. Then you have the type of solution you want to output. Are they carbon optimized? Are they cost optimized? When you run Panda, you will soon discover that these tend to be close, with typically the exception of concrete decks, where there is typically a pretty clear trade-off between cost and carbon depending on the price of steel. And similarly, the choice of foundations. It's frequently the case that pile foundations are lower carbon but more expensive, and this is something you might want to see. Either way, I would recommend having both. What this does is you can have, Panda will generate a bunch of grids. Every grid will it will try every single decking for every grid, and you may want to keep the best, so that would be best cost, best carbon for every layout that it has generated, for every general decking type, or, and this is the default, keep every option. I recommend doing that because that gives you a sense of all the possibilities for your design. Then we progress on the tabs. Vertical layout. We may want to try alternate story numbers. That is, it's of course enormously valuable to be able to have more stories, particularly in city centers where there's a vertical limit, but the maximum number of stories is also typically the maximum economic value. And Panda will do that. You describe your requirement in terms of the vertical buildup of your space, and it will then try every story that it can, every story number that it can, matching these requirements. And importantly, you may try to improve that by allowing more detail options on your beams. For example, steel beams could have little shelves on the web, allowing the beam to go into the decking, or bottom flange bearing, that is your slim deck kind of arrangement, where the decking are held by the bottom of the beam. Surfaces could be below the beams, which is the most common option, or through the beam, through opening. And if that's the case, the surface penetration zone will be used to determine the size of those openings, and of course that will limit the total height of that will impose some condition on the total height of the beams. Then we will move on to the loading input. The type of building, this changes safety factors somewhat. Storage here also changes the number of secondaries which will be allowed. Normally, by default, and you can change that in the option, Panda will try to return only the options with up to 2 secondaries. However, storage buildings with very high loading are more commonly built with a much larger number of secondaries, and this limit is skipped if E is automatically skipped if E is selected here. You can load in detail your structure. In this case, it's a very simple structure, so detail loading does not show you very much, but you can very well have a massing where part of the structure is heavily loaded and part much less so, and this is where you would do it. This is the default loading, depending on which part of the building we're talking about. And of course, the loading of the facade. Now, the loading of the facade is fairly simple. You can have a separate parapet load, the facade load, and you can have alternate build-up for the load of the facade. Panda does not design facades, but it's important to consider the loads, and it's important to consider the requirement for serviceability of the facade. And so this can be used to compare different options depending on the type of facade you would be considering. Then we move on, serviceability, your deflections and vibration, including the edges. And then we move on to the substructure. So the foundation floor, you can have, the default is a suspended two-way slabs, or you can simply have a ground-bearing slab because you know this is appropriate and you would have to enter the values, and Panda would not do design, it would simply use the input values. You can configure the soil and foundation. So there's a complete geotech module in Panda. Early stage design, usually you do not have a detailed geotech report for your site, but you may have one because maybe you're building on some already known site, or maybe this has been commissioned for whichever reason. In which case, if that were the case, you could use all the strata and build up the story model, and it would use that to calculate capacity. Or more commonly, you would have allowable bearing pressures and capacity table for your piles and pads and rafts. And this is what it would use. Some options, you can, it is allowed to reduce the tests if you do some loading tests. You can reduce the safety factor and you can activate that. This is sometimes a valuable option in larger projects. And depth for the ground, etc. This is basic. It does full geotech design. And this is where I like to point out, Panda will not read from a database because, as I said, we know from our academic studies that it's not the case that you can read from a database simply because, on average, buildings are massively overbuilt and they have picked previously not the optimal decking. So if I used a database of existing buildings, I would most likely use suboptimal design. So I have to design it from scratch to be certain that I am doing the right thing. Moving on to the superstructure, the types of decking I would consider: flat slabs, waffle slabs, the size of the concrete columns I would allow, composite prefab, and also special slab tab. In future releases of Panda, there will be a graphical editor allowing you to create those the input files that are listed here, and you would just add them in the resource directory and Panda would load them. You can already do that today, but you have to fire up your text editor and probably copy paste one of these and adapt it as required. They're fairly simple to create. Separate roof design is possible. So if you want to click on this button, what this will do, it will consider separate the different type of decks for your roof, and this is particularly useful if you want to have a lightweight roof, or simply for aesthetic reasons. You may want to have the upper, for example, your roof might be made of timber. It's light and has aesthetic benefits, so you might want to do that. This is how you would activate this. Panda does not, in fact, design cores. Core design is a very bespoke thing. However, we find that designer will have a good sense of the size and the material inputs in their cores, and you can add it. It's particularly useful if you want to make a comparison between a core stabilized design or a braced design. Panda will design the bracing if you ask it to. This is the lateral stability system. I'm not going to activate it here, but it would do that. If it is a steel frame, it will use steel bracing. If it's a timber frame, it will use a timber shear wall. If it's a concrete frame, it will use a concrete shear wall. And you can also ask it to try concrete shear wall anyway. They're cheap and efficient, and so it will do a comparison. And like for everything, it will both find the cheapest and the lowest carbon option. Finally, fire design. You set your fire resistance. Panda does full fire design in the case of concrete. In the case of steel, it will calculate the appropriate amount of intumescent paint. In the case of timber, it will add the appropriate number of gypsum plasterboard. Having done all that, you click run. And you see that Panda has determined that there were, in principle, nearly 3,000 options, and is going to run through every one of them. And of course, a number of them are not possible, and so they will be discarded. And you can see them being displayed here. This is the ABCDE is the I/T scale, as recommended by the I/T, and you have the cost and the carbon, and you can see these things being displayed here. Whilst it's running, I'm just going to show you a few things that you can consider. Panda is not a black box. All the values are there for you to see and modify as appropriate. First, the LCA, concrete, steel, timber, and the rest of the carbon components, including the various distances. These are default recommended distances, but of course you should adapt them to your specific site. And this, and you can see all the values, and they can be recalculated, and you can set as a default. If you have typical values your company uses, you can create a new default and it will open automatically. These are simple text files that you can put in the resource directory, and they will be loaded as appropriate. The costs are also not they're also not a black box. You can see all the values that go in, all the rates, and you can know how the cost was calculated. This, of course, should be adapted, with your QS and have a discussion what is the best value to have a better guess. However, they should be sensible. The default should be sensible and help guide your decisions. You see here, these values have been updated for that period. And if you're a Panda customer, we update those values every 6 months or so. Panda is not a black box. It's not just the cost and carbon values which are clear, but it is also, if I click on any one of these solutions, let me move this a little bit, we can see that's my layout, and I can see including the elevation, and I can click on every one of these bays, and I can ask for an engineering report. And the engineering report will give you all the engineering tests for all the beams and columns and decking that governed this specific selection. And that way you can look at the design, and this is meant to help you when you move on to the final design. This is meant to help you get a better result. You can see here the cost and the carbon breakdown, also by materials and operations, and this can help you also know what are the pain points for your structure. Because it is not sensible to output that many options and present them to the client, you need to be able to filter them down. And there's a whole options here to do the filtering, the carbon, the cost. Mass here is important because maybe you're not designing a building, you're in fact designing a vertical extension, and therefore it is all mass that needs to be limited. You can verify that your building is within best cost and best carbon, and you can then filter by all sorts of things such as the deck system, the number of stories, whether there are transfers, and so on and so forth. Finally, you can explore design option and design drivers. So this was my baseline set, which I'm just going to let it finish before I save it, but I could save it at any point. And having done that, I can then compare and see what happens if I change my my design option, my design requirement. So this was my option, and we can also, of course, use the visualization to understand what is driving cost and carbon in those options. Column spacing is a very common driver. Of course, larger spans imply more carbon, and we know that, of course, as engineers. But it's useful to be able to put a number on it. And we can see here that going from very small spans has the benefit that it allows you for those softwood joist structures here. So that's one of the reasons you might want to have the smaller spans. But for example, steel or concrete structure, the effect is not as large. However, going to much larger 9-12 meter spans has a big impact in cost and carbon. And so this is how it works. You can also look at other things. For example, you could have a sense of the structural zone depth, which is typically an important consideration. How much scope do you have for vertical optimization, and so on and so forth. Circularity index here. Materials are more or less recyclable, and your structure is made of more or fewer materials that can be reused and recycled, and this reflects the overall makeup of your structure. So it's finished running it, and just to show you how this is meant to work, I'm going to save this set as my baseline. And for example, we can look at what the effect is of picking, for example, another LCA cycle. In this case, let's try to cradle to cradle. And maybe, well, it's good to change a single parameter at a time, but I could change a number of them. I could change my layout to have a different option, and so on and so forth. And here, if I compute, what you'll see is it keeps the previous one, and we can see the new results appearing as we're running. And we can see this shift on the left, of course, because module D is now allowing for recovering some of the carbon. And let me go back to frame so we have a sense of what's going on. So this is this is basically what Panda does. And the purpose of Panda is not to automate the job of an engineer. That's not something it can do or could do. The purpose of Panda is to help the engineer at the early stages of the project be effective, to know what the overall scope of options is, what is possible, and to make the best informed decision very early on when they have the maximum impact and can provide the maximum benefit both in terms of costs and in terms of carbon. Thank you very much.